Welcome to the deep dive. Today, we are taking on a single, absolutely enormous topic, artificial intelligence. And we're diving deep into this massive stack of sources you provided us. We've got national AI strategies, groundbreaking science journals, some really critical studies on human cognition, and even complex legal analyses of intellectual property.
It's an extraordinary collection. And what it really illuminates is, the central tension of our technological age. We are not just looking at a linear step forward in computing.
No.
We are analyzing what one of the policy documents calls a seismic shift. It's something that is rewiring the engines of research. The speed of progress is, well, it's dizzying, but so are the ethical and systemic risks.
Absolutely. And that's the core of it, right? AI is simultaneously the most powerful scientific tool humanity has ever created. I mean, it's propelling us toward what feel like utopian levels of discovery, while also introducing these profound systemic risks. So our mission today is to really understand this fundamental duality. How is AI accelerating breakthroughs to warp speed while also creating these hidden hurdles, like, the erosion of our critical human intellect and even the contamination of our entire data ecosystem?
The opportunity is immense, but the hurdles are, well, they're existential. We have to unpack both sides. And the sources, they consistently emphasize that this moment demands not just passive adoption, but a really comprehensive strategic response.
A plan.
A real plan. This is being viewed as a national imperative, especially in the UK context that's highlighted in these documents. And it requires a new research strategy, one that prioritizes bold, coordinated investments in data, tools, and talent to make sure the entire R&D ecosystem becomes, more dynamic and entrepreneurial.
It's about building a better engine, not just driving faster. Okay, so let's jump straight into the accelerant. We'll start with how AI is acting as a scientific accelerator. This is where all the headline-making, groundbreaking discoveries are happening. And if we look for the clearest, most referenced example of AI solving a problem that's been around for centuries, we have to start with the AlphaFold revolution.
AlphaFold is the perfect illustration. It's a domain-specific innovation that just delivered a complete paradigm shift. For decades, the protein folding problem was a grand challenge in biology.
And why was it so hard?
Well, because predicting a protein's 3D structure just from its 1D chain of amino acids, its sequence, it involves a combinatorial explosion of possibilities. A protein with just 100 amino acids has more possible shapes than there are atoms in the universe. It was a computational nightmare.
Right, so the traditional methods were incredibly slow and expensive. Things like X-ray crystallography. You'd have researchers spending years, literally years, trying to figure out the structure of a single protein.
Exactly. And AlphaFold, which came out of DeepMind, it leveraged deep learning. It trained on the limited but essential data in the public protein data bank. And that training allowed the AI to develop this uncanny intuition, a predictive ability that just surpassed decades of human-led effort. It's like a computational oracle for predicting structure.
And the impact is what really matters here, not just the technical wizardry. The scale of the shift is just unprecedented.
It is, and the output isn't locked away in a proprietary vault, it's open access. The AlphaFold database now offers over 200 million protein structure predictions.
200 million?
It's not just a research tool anymore. It's a new fundamental baseline for biological understanding. For any biomedical researcher today, having instant access to that database just dramatically accelerates everything from understanding disease to designing new drugs. It collapsed a major bottleneck in life sciences almost overnight.
So that's biology. Let's shift gears completely to materials science. The second big breakthrough the sources highlight is GenoMe. It stands for Graph Networks for Materials Exploration. The name GenoMe, it sounds a little quirky, but the impact is anything but.
GenoMe, also from Google DeepMind, addresses another massive bottleneck, but this time in inorganic chemistry. When you're trying to design new things like battery materials, superconductors, advanced alloys, the critical first step is predicting if the new crystal structure will be stable. It's computationally intensive, and a lot of the time, traditional methods just lead to unstable, useless results.
But GenoMe works at an entirely different scale. I mean, I had to read these numbers twice. The system discovered 2.2 million new materials.
It's wild.
And if you put that in context, the sources estimate this is equivalent to about 800 years worth of knowledge accumulation if we were doing it the old way, manually. That isn't just acceleration, it's a phase change.
And that scale is paired with reliability. GenoMe achieved an impressive 80% precision for its stability predictions. But what's truly disruptive is the feedback loop this creates. This discovery isn't just theoretical, sitting in a database waiting for a human to find it.
This is where the AI to lab pipeline comes in.
Precisely. The genome predictions are already being used by autonomous robotic laboratories. The A-Lab at Berkeley Lab, for instance, it takes the stable compounds predicted by genome and physically synthesizes them with minimal human input.
So the AI finds the promising candidates.
And the automated lab does the complex, precise chemistry to actually create it. This means the entire discovery to creation cycle, from an idea to a physical thing, is becoming machine-driven. Yeah. You're seeing the birth of automated physical science.
It's astonishing. It feels like AI is accelerating the creation of reality, not just simulating it. And we see this automation trend affecting global systems too, right? We can quickly mention GraphCast for climate and weather.
Oh, that's another perfect example of replacing complexity with pattern recognition. Traditional weather forecasting relies on integrating these incredibly complex physics-based equations. It requires massive supercomputers and takes a long time to run.
Right.
GraphCast uses graph neural networks trained on decades of weather data to just spot patterns. You can produce forecasts for global weather cyclones, atmospheric rivers in minutes on a single machine, and its accuracy often rivals or even beats the traditional models. It just swaps brute force physics modeling for data-driven elegance.
Okay, so we've established AI can solve these grand challenges in specific fields. But now let's zoom out to the research process itself. The sources talk about reinventing the research workflow. It seems like AI is also becoming the ultimate administrative assistant, taking over what some of the sources call scientific drudgery.
That's the quieter revolution, but maybe the more pervasive one. AI is being embedded throughout the entire scientific workflow. You've got AI-assisted programming, helping researchers write better, faster code, automated data collection handling vast amounts of information, and large language models, LLMs, taking over literature reviews, generating hypotheses, discussing results, and speeding up the writing process.
So it frees up the human scientists from all the tedious, repetitive stuff.
Exactly. But we are moving beyond just a sophisticated assistant. The sources introduce a concept that is, I think, truly fascinating. The co-scientist. Not just a tool, but a true collaborator, a partner.
A partner.
We are indeed moving beyond mere assistance into true intellectual automation. Take the AI co-scientist developed by Google, built on Gemini 2.0. This is a multi-agent system designed to automate the intellectual core of research, generating, debating, and refining hypotheses. It's basically simulating a really good and sometimes argumentative lab meeting.
So the AI isn't just summarizing text, it's actively participating in the scientific method itself, the core human enterprise. Yeah. How does it structure that debate internally?
It uses a structured multi-agent architecture. So you have a generation agent that rapidly proposes diverse hypotheses. Then, a reflection agent acts as a devil's advocate, critiquing those ideas for flaws or bias. The ranking agent scores them based on feasibility and impact. And finally, the evolution agent takes the best ideas and refines them, moving toward a final theory set by a human in just natural language.
That formalized internal debate is key, and we have a really compelling case study of this kind of system from Future House, a nonprofit AI lab. Their whole mission is to build an AI scientist that can scale discovery beyond human limits.
Yeah, they developed an architecture they named Robin, which includes specialized agents with names like Crow, Falcon, Owl, and Phoenix. Each one does a unique intellectual job. And they applied Robin to a deeply complex problem, dry, age-related macular degeneration, or DMOD.
Which is a leading cause of blindness. And the challenge here is just the sheer volume of literature and how poorly we understand the disease, right?
Exactly. It's overwhelming scientific noise. And Robin's breakthrough was that it autonomously proposed a therapeutic strategy. It focused on enhancing something called retinal pigment epithelium, RPE, phagocytosis.
What's that in simple terms?
It's basically the process where certain cells clean up damaged photoreceptors in the eye. When that cleaning process fails, it contributes to the AMD. So Robin's strategy was, if you can boost this process, you can slow the disease.
That's the conceptual breakthrough. But the next step is what really validates this whole co-scientist idea.
It really does. After proposing the strategy, Robin identified a drug called ripasudal as a promising candidate. Now, ripasudal is a clinically used drug. It's an anti-glaucoma agent, but it was previously completely unassociated with DMD, or this specific cleaning process.
So it connected a known drug to a brand new mechanism in a different disease context, all on its own.
All on its own. And later lab validation confirmed the drug's potential. That ability to repurpose a drug, connecting fields that humans hadn't, proves these systems can drastically cut down the time and money needed for therapeutic development. That process usually takes years. Robin did the intellectual heavy lifting in a fraction of the time.
It's the sheer efficiency of intellectual cross-pollination. AI doesn't see disciplinary boundaries. It just sees correlations across all of human knowledge.
Right. And moving from that intellectual automation to physical automation in drug discovery, AI is also changing how we approach efficiency and safety in drug design itself.
How so?
Well, we see AI platforms like those from AtomNet using deep learning to predict how molecules will behave and to optimize their structures. For instance, in silico medicine hit a big milestone with a fibrosis drug candidate that entered phase 2 trials. What was so remarkable was that the entire molecule was generated end-to-end by deep learning. The AI can filter out compounds with potential safety or efficacy problems really early on, which streamlines the whole pipeline.
And then we get to the really cutting-edge interface of AI and biology. Organoid intelligence, or OI. This is where we start to blur the line between models and life itself.
OI represents the integration of AI with what are called microphysiological systems, or MPS. Think of them as organ-on-a-chip technology, mimicking human organs in a lab dish. The research in this field has got up by 1,500% in the last decade. It's seen as completely necessary for creating highly accurate human models.
So how does the AI contribute here, beyond just running the machine?
The AI extracts what are called rich morphological embeddings and temporal signatures from high-content imaging.
Okay, break that down for us.
Sure. Morphological embeddings means the AI can identify incredibly subtle changes in cell shape, structure, and arrangement details a human eye would struggle to catalog across thousands of images. Temporal signatures means the AI tracks exactly how those cells react to a drug over time. This allows for hyper-accurate simulations of human organ responses, which is crucial for advanced disease modeling and drug testing.
The ultimate next horizon mentioned in the sources, the one that really forces you to pause, is using neural organoids interfaced with microelectrode arrays.
This is where the ethical discussion really begins, and the sources say we can't postpone it any longer. We are talking about electrical activity in these brains in a dish being modulated by reinforcement learning algorithms.
So the AI is using these tiny biological systems as part of its own learning loop, a biodigital hybrid.
Exactly. And we have to ask if these entities evolve beyond just being models. If they start to demonstrate complex learning behaviors, what is our moral obligation to them? The question shifts from, is this a good model, to,
is this an entity we need to consider ethically? It pushes the philosophical boundaries of what constitutes sentience or a morally considerable being. That is definitely a development to watch.
It's undeniable. AI is accelerating knowledge production everywhere. But now we have to transition to the flip side of that coin, the risks. If AI is outsourcing so much of the foundational cognitive load of research, what happens to the human intellect itself?
This brings us to Section 3, the risk to human intellect, and this idea of cognitive atrophy and the end of theory. The key mechanism at play here is cognitive offloading.
Cognitive offloading is basically delegating cognitive tasks. Anything from remembering a phone number to complex problem solving to an external tool.
Like using a calculator or a GPS.
Exactly. But now we're offloading high-level tasks, writing, synthesizing information, critical analysis. We're giving it all to AI.
And we aren't just speculating about the consequences. The sources detail a really comprehensive study with 666 participants, specifically looking at the link between frequent AI tool use and critical thinking skills.
Yeah, the study measured critical thinking using the Halpern Critical Thinking Assessment, or HCTA. It's a robust tool that covers 5 areas: verbal reasoning, argument analysis, hypothesis testing, and so on. The results were stark. A significant negative correlation was found between how often someone used AI tools and their scores on that test.
I found that data point truly unsettling. The more you relied on the AI, the lower your ability to critically assess arguments and form hypotheses yourself. So why is this happening?
The study identified cognitive offloading as the key mediator. By delegating complex tasks, the AI reduces the required cognitive load on your brain. Now, that sounds efficient.
That's not good.
It's not. That reduction in load means you have less reason to exercise and develop those neural pathways. It's like outsourcing your physical fitness. You might get the results, but your own muscles atrophy. The study's analysis confirmed this detrimental effect that increased reliance on AI had on fundamental critical thinking scores.
There was also an interesting demographic nuance. Younger participants who are digital natives showed a much higher dependence on these tools. It's just a natural part of their workflow. And they had consequently lower critical thinking scores compared to older participants.
That finding does suggest a kind of generational learning curve. However, the study also found a mitigating factor: higher education. participants with advanced degrees had better critical thinking skills, and the data suggests this educational foundation might build a sort of protective cognitive layer against some of these negative effects.
And this is all tied up with trust, right? The paradox is the more coherent and reliable the AI sounds, the more likely we are to just offload the task.
Yes, exactly. Increased trust, even in things like virtual influencers presenting themselves as reliable sources, leads directly to more cognitive offloading. When the AI sounds right, we stop doing the deep verification or critical appraisal. We just delegate, and that cycle reinforces the diminishment of our own cognitive abilities.
So let's shift to the philosophical side of this risk in science, this worry about the end of theory. We just saw AI reduce a problem like protein folding to a few hours of computation. I mean, does that make worrying about fundamental principles kind of irrelevant if the what is instantly solvable?
That's the critical question. The concern about the end of theory is that over-reliance on AI's opaque methods, the black box, will pull science away from hypothesis-driven inquiry and towards purely data-driven correlational approaches. If the machine can generate a result with 99% accuracy, why bother with the messy, difficult work of figuring out why?
And the consequence of that, if we stop asking why, is that we lose the ability to generalize.
Precisely. We lose fundamental scientific understanding. We might have a perfect drug synthesized by an AI, but if the AI can't explain the mechanism to us in human understandable terms, we can't apply that knowledge to similar diseases or new contexts. Rigorous justification gets sacrificed for useful results. This trend risks reducing science to a massive search function rather than a process of continuous intellectual comprehension.
We also have this debate on homogenization versus freedom. On one hand, AI handles the drudgery, freeing up researchers for high-level thinking. On the other, if everyone is using the same foundational models, will all research start to look the same? Will it all converge on what the machine thinks is tractable?
That convergence risk is really serious. The sources cite studies on creativity showing that while generative AI can boost individual creativity, because the tool makes it easier and faster to create, it might actually reduce the collective diversity of new content. Everyone starts using the same popular model, leading to a convergence in style or argument. The serendipitous, weird, high-risk exploration that leads to real paradigm shifts might get screened out by an algorithm that's just looking for the most probable outcome.
So if we accept that AI is here to stay and we want to prevent this cognitive offloading, we can't just ban the tools. We need smarter ways to use them. This leads us to the pedagogical shift proposed in the sources, the Socratic solution.
Right. The standard way students use AI is generic prompts like explain the causes of the American Revolution. That just encourages passive consumption. The AI gives the answer, the cognitive work is done. The Socratic AI tutor model flips this completely. Instead of giving a direct answer, the AI is prompted to ask the student thoughtful, challenging, open-ended questions. It's designed to guide their thinking and force them to engage in metacognition.
So you're basically training the AI to force the student to think rather than just receive information. It upholds academic integrity while building skills. So what did the research show about how students perceived this approach?
The studies confirmed it was effective. Students found the Socratic AI feedback useful and engaging. It helped them promote deep learning and identify gaps in their knowledge. Crucially, they reported greater support for critical and reflective thinking when using the Socratic tutor compared to just a passive chatbot.
That sounds extremely promising, but the technology still has its flaws and the students were keenly aware of them, right?
Oh, absolutely. Students raised critical concerns that we have to address. The three main risks they identified were AI hallucinations, plausible but false information, as well as randomly generated responses or feedback that was just too generic. And because of these issues, students still overwhelmingly preferred feedback from a human tutor.
Which highlights the need for tutor mediation.
Exactly. You still need the human to validate the AI's output and tailor the Socratic process. The human provides the trust.
This idea of prompt design seems crucial. Our sources highlighted a framework for this, the CTCE framework. If we're going to rely on AI to guide thinking, the instructions we give it have to be robust.
This is a key tactical takeaway. CTCE stands for context, task, constraints, and ethics cue. A weak prompt is passive. A strong CTCE-compliant prompt is active and intentional. It's like a mini lesson plan for the AI.
Okay, so let's break those down, starting with context.
Context is about setting the role. You tell the model its identity. For example, you were an AI tutor for a 10th grade English class, specializing in reflective writing. This is critical because studies show that giving the model a clear identity and goal can increase its accuracy by up to 31%.
Then we have the task.
The task is the clear, actionable verb, what you want the AI to do. Not give me information, but critique the student's argument, generate counterarguments, or ask 3 thoughtful questions about their conclusion. It forces an active engagement.
Constraints set the rules of the road.
Constraints are all the limits.
Yeah.
Word count, reading level, tone-like. Maintain a supportive but skeptical tone. This prevents the too generic problem and makes sure the output is aligned with the learning goal.
And finally, the ethics cue.
The ethics cue is the signal for responsible AI. It actively mitigates known biases. For instance, instructing the AI to ensure the questions are inclusive or check your response for gender and racial stereotypes before presenting it. This is how humans actively steer the tool away from the biases in its training data.
So we've established that AI usage can diminish human intellect. But its internal operations, the training data that feeds it, faces an even more insidious existential threat: data contamination. This takes us to Section 4, the threat to data integrity, also known as AI model collapse.
This is maybe the most fascinating risk because it's entirely self-inflicted by the AI ecosystem. Model collapse is the progressive degradation of an AI model's performance, and it's caused by recursive training. Essentially, a model is trained on synthetic content data generated by other AI systems, rather than original human-generated ground truth.
It's the ultimate echo chamber, or like making a photocopy of a photocopy of a photocopy until the image is just unrecognizable.
That analogy is highly accurate. If you picture the internet being flooded by AI-generated text, images, and code, and then the next generation of LLMs ingests that contaminated content, the model gets stuck in a feedback loop. It reinforces its own mistakes and biases, leading to a severe loss of data diversity, accuracy, and meaning.
And what are the visible consequences of this? What would listeners actually start to see in their AI interactions?
Well, the output quality just plummets. In the sources, they call it semantic drift, or output entropy. At first, the errors are subtle, statistical. But eventually, the model's ability to produce accurate or creative text noticeably diminishes. You'd start seeing frequent nonsensical sentences, more factual inaccuracies, hallucinations, or just a frustrating repetition of the same phrases and ideas. If this cycle isn't broken, the integrity of all next-generation models is fundamentally jeopardized.
And why does this statistical distortion, this data distribution drift, happen so easily right now?
In the early days, massive models like GPT-3 were trained on vast, relatively clean sets of human-generated data. Books, articles, academic papers, that was the ground truth. But now, as AI content generation scales exponentially, much of the new data online, blog posts, summaries, images, comes from AI models themselves. So new models inadvertently ingest this contaminated data, learning from degraded or simplified signals.
And the lack of fresh, original human data means the model gets further and further from the actual complexity and nuance of reality.
Precisely. If a model only sees copies of its own outputs, it loses the richness and statistical variety of human input. The subtle errors in the first generation of AI output become amplified in the next. It's a crisis of intellectual inbreeding, where the information pool just shrinks with every training cycle.
So, is model collapse an inevitable doomsday scenario for the future of AI, or can we stop it?
It is emphatically not inevitable, but it requires immediate active mitigation. The risk is high because right now the speed of AI development often prioritizes quantity over data quality. Prevention demands stringent data governance and intelligent training strategies.
So what are the key strategies we need to employ to prevent this collapse?
There are 3 critical strategies highlighted. First, we need to ensure a sustained influx of high-quality, diverse human-generated data in the training mix. AI developers have to actively seek out and prioritize fresh, unique human contributions.
And then we need a way to identify the copies.
Exactly. The second strategy is implementing robust provenance control. This means creating things like digital watermarks or labeling protocols to identify and filter AI-generated content. If a model has to learn from AI content, it needs to know that it's a derivative signal, not a ground truth observation.
And the third strategy brings us back to the human element.
It does. Use human-in-the-loop feedback. Humans have to regularly review and correct the model's outputs and its training data. This process steers the model away from bad habits and ensures the feedback loop stays grounded in human judgment and reality. It's a constant corrective force against this semantic drift.
Moving now from data integrity to intellectual integrity, AI is fundamentally challenging our legal and ethical concepts of ownership and creativity. This takes us to Section V, AI and authorship, the creative and legal battlefield.
This is one of the most contentious legal areas globally right now. Generative AI can produce material that is aesthetically and functionally identical to human-created work. Yet, across major Western jurisdictions, copyright law faces this philosophical hurdle. It maintains that human authorship is a bedrock requirement of copyright.
Which means, in the US and the EU, works generated entirely by an AI are generally not protectable. A human has to be the author. What's the required threshold of human input?
The threshold is high. The work has to be the author's own and display some minimal level of creativity, the spark of human originality. Merely supplying a generic prompt like "generate an image of a red sunset" does not qualify as enough human expression or intellectual contribution.
But if a human creator uses the AI as a tool like using Photoshop and contributes original expression, the work can still be protected.
Yes, and the ambiguity is in that gray area of how much human input is required. Does drafting original text that specifically guides the model count? What about extensive post-production editing or making specific artistic choices? These details are being actively litigated right now, and they're what determine the difference between a human who just presses a button and one who exerts creative control.
That distinction highlights the tension, but the global perspective is far from united. Our sources highlighted the China precedent as a massive divergence from the US-EU stance.
It's a critical contrarian step. The Beijing Internet Court in the Lis v. Liu case granted copyright protection to an AI-generated image. This decision directly challenges the Western focus on human originality.
And their reasoning was centered on this concept of intellectual investment.
Correct. The court argued that the user who structured the prompt, arranged the elements, and selected the final image performed the necessary intellectual investment. They viewed the AI model as a sophisticated tool, like a camera or a commissioned painter, an entity without free will. By recognizing the copyrightability, the court aims to encourage the use of the latest technology and protect the user's investment. It prioritizes economic encouragement over the strict requirement of human-only originality.
That divergence is critical for international IP law. But beyond the legal gymnastics, there's a fundamental ethical issue with the content itself: the inherent bias and integrity of representation in AI-generated art.
This is a direct consequence of training these models on skewed, real-world data. AI models, trained on data sets that feature predominant cultural styles from online sources, naturally reflect and powerfully reinforce those biases. They often perpetuate harmful stereotypes and severely limit the diversity of the output.
Let's review some of the specific examples of this bias, starting with gender.
The studies on gender bias showed disturbing results. When vague terms were used for people, the AI heavily reinforced stereotypes. Women were consistently shown with domestic items, like vacuum cleaners, while men were shown with tools or vehicles. Furthermore, AI image generators created men more often for nearly all professional jobs, perpetuating occupational segregation.
And it's proven really difficult to remove this bias, isn't it?
Extremely difficult. Researchers tried complex strategies, including using biosemiotics and deliberately adding non-binary images to the training set. But these efforts were largely unsuccessful in steering the AI away from its learned stereotypes. The bias is just. It's deeply embedded.
And racial and occupational bias is just as prevalent.
Absolutely. One study on the surgical profession found extreme homogeneity. 98% of all AI-generated depictions of surgeons were white males.
98%.
In other contexts, you see extreme overrepresentation. For example, studies found that 95% of prompts with words like studying or math resulted in Asian individuals, reinforcing the model minority stereotype.
And there's a compelling example of cultural misrepresentation regarding South Asia.
Yes, a notable study examined Meta's AI image tool when generating images of Indian men. A staggering 75% of the resulting images show the men wearing turbans. The reality is completely different. Less than 2% of Indian men regularly wear turbans. On top of that, the study found these AI-generated images often depicted Indian men with markers of lower socioeconomic status compared to their white counterparts, showing a learned bias based on skewed online data.
Finally, let's address the perception of value. If AI can produce visually stunning art so easily, what does that do to the intrinsic value of human artistic labor?
This is a huge ethical concern tied to the economics of creativity. Experiments show that while AI-generated art can achieve high levels of likability, people find it enjoyable. It currently lacks the intrinsic value that viewers tie to human intent, effort, and craftsmanship. When we look at traditional art, we value the perceived struggle, the skill, the narrative intention behind it. The speed and ease of AI generation raises deep ethical concerns about the potential devaluation of artistic labor, which can make it harder for human artists to command value.
So we have hyperacceleration on one side and profound systemic risks to our intellect, our data, and our culture on the other. This duality demands a comprehensive policy response. Section 6 is all about remaking institutions and science for the AI era.
Yeah, the documents make it clear that a successful national strategy has to comprehensively address 5 key enablers: data, tools, talent, infrastructure, and institutions. It's not just about optimizing the systems we have, it's about a complete institutional overhaul to manage this force multiplier responsibly.
Let's focus on talent first. The brain drain from academia to industry is a massive challenge. Skilled AI researchers are drawn away by high salaries and advanced resources in the corporate sector.
This creates a critical knowledge gap in fundamental research. The proposed solution is to create pathways for hybrid roles and what's called cross-sector mobility fluid movement between industry and academia. The current system is too rigid. Researchers who leave for industry rarely return. So policy has to incentivize feeding that industry expertise back into academia through shared appointments, consulting roles, or sabbatical programs.
And then there's the massive energy requirement. Infrastructure and compute demand a lot of attention, which is often overlooked.
The energy demands of AI data centers are a huge infrastructural hurdle. Policy has to mandate the rapid upgrading of the electricity grid to meet this need. Furthermore, national energy operators must be tasked with evaluating how data centers use energy. It's often in massive but episodic bursts, and incorporate that into national energy plans. This isn't just an IT problem, it's a national energy security issue.
And regarding institutional modernization, how should funding bodies like UKRI adapt?
Research funding bodies need a fundamental shift. They have to formally increase dedicated investment in AI-enabled research and establish new, agile programs to encourage AI adoption across all fields, not just computer science. And crucially, institutions need to establish a new central AI function, as proposed within UKRI, to drive frontier research and coordinate strategy across the entire system.
This coordinated effort leads to a larger philosophical shift. The sources define as moving beyond science, powered by AI, to scient science, optimized for artificial intelligence.
Science is the new paradigm. It's an acknowledgement that the way we produce and share knowledge has to change to be compatible with machine analysis. The core premise is revolutionary. The body of public knowledge will increasingly be defined by what is machine-readable, not just a library of prose written for human eyes. AI learns from structured data, tokens, tensors, linked data, and its performance is directly tied to the consistency of those representations.
So if a publication buries crucial experimental details, like the prompt parameters for an AI system deep inside dense text, it's basically useless to the next AI trying to learn from it.
Exactly. The shift requires a fundamental reorientation of scholarly norms toward openness, standardization, and machine interpretability. We need interoperable formats for methods and results so the AI can ingest, compare, critique, and reuse the information at massive scale.
This seems like a direct countermeasure to the risk of opaque AI systems magnifying existing problems, like the reproducibility crisis.
It is the necessary governance response. To force transparency, governance frameworks should mandate detailed metadata recording for every AI step in research details like prompt parameters, temperature settings, and hardware details. This needs to be compiled in standardized checklists like START AI, mirroring the rigorous data requirements we expect in clinical trials.
Finally, we have to return to that worry about the end of theory. If efficiency is the guiding force, how do we protect the messy, necessary human element of curiosity and exploratory research?
This is a significant dilemma. If algorithmic optimization causes research agendas to converge only on machine-tractable problems, questions easily solved by current data, we risk inadvertently deprioritizing exploratory high-risk inquiries that lack an immediate computational payoff. These are the weird, expensive studies that historically lead to massive, unexpected breakthroughs.
So the governance framework needs to actively reward non-optimization.
Precisely. It must incorporate diversity of approach metrics alongside traditional efficiency scores. We need to explicitly reward methodological pluralism, unconventional study designs, and high-risk, curiosity-driven exploration to preserve the creative breadth that has always been the driver of transformative science. We need to make sure we keep asking questions that the machine can't yet formulate.
We've covered everything from AlphaFold solving the secrets of proteins to the risk of AI-generated content creating a future of digital collapse. The dual nature of AI, the superpower and the systemic threat, is just undeniable.
The synthesis is that AI is an unprecedented force multiplier. It combines the leverage of fire, the infrastructure of electricity, the power of mathematics, and the relational interface of language all into one technology. It offers personalized education, instantaneous problem solving, and automated discovery at a scale we are only just beginning to comprehend.
But the real challenge isn't purely technical, it's the psychological and philosophical impact on us. We're dealing with systems that can simulate understanding without consciousness, provide comfort without care, and offer solutions without the kind of human wisdom that comes from lived experience and struggle.
The enduring challenge for humanity is maintaining authentic selfhood, epistemic agency, the ability to know and think critically for ourselves, and nurturing our inherent curiosity. We have to ensure that AI remains a tool that genuinely amplifies human intellect, rather than driving us toward a pervasive, comfortable dependency that diminishes the core of what it means to be a researcher, a creator, or simply a discerning human being.
Which leaves us with this final thought, something for you to mull over after this dive. If AI gets so much smarter and so deeply integrated into our systems that we no longer fully understand how we are being shaped, if it's like a researcher moving the walls in a mouse's maze well beyond the animal's comprehension, how do we ensure that the goals of these enormously powerful algorithms remain aligned with amplifying human curiosity and discovery rather than just optimizing for machine-tractable efficiency and, ultimately, our own cognitive substitution?
The future of knowledge depends not just on building smarter AI, but on designing the relationship between human and machine to be one of constant, critical augmentation, not comfortable, quiet substitution.
That's a wrap on this deep dive. We hope you feel slightly more informed and significantly more provoked.